So my name's Ian Lee. I'm a security architect and the security operations team lead at Lawrence Livermore. For those of you that aren't so familiar with the Department of Energy, we make up 17 national laboratories. We're the one located over here on the West Coast. Maybe that's the farthest traveler, not sure. But the division that I sit in is the High Performance Computing Division. So this is a division of about 120 people. Our primary mission is to support the high performance computing environments for our users. We have something like 3,000 to 4,000 users internally and externally, depending on the system, across multiple different networks in the Department of Energy. So we sit on the National Nuclear Security Administration side of the lab, or of the DOE complex, which means that our responsibility primarily is stockpiled stewardship, as well as advancing science in the nation. So NIF, the laser ignition, was a part of that work. When users look at our systems, they see something like this. So the big red bubble there, the size of the bubbles here is the theoretical peak performance of the systems that we have. The red one there is Sierra. That's our current largest system. It was #1 on the top 500 list for a while. I believe it's currently dethroned by Oak Ridge. I don't know that they've been outdone yet. But this is what our users see, right? Some, modest compute capabilities here. Not too many systems overall. The big performance systems are just a handful. When we as the staff for our center look at the system, this is what we see. We see north of 200 actual clusters comprised of anywhere between 2 or 3 up to thousands of nodes in a single cluster that do the actual compute work that our scientists rely on. And this is spread across a couple of different environments. We have different unclassified enclaves more for collaboration, more for our restricted codes. We have classified environments on different networks. We have other folks that use our systems elsewhere. And this is what our environment looks like. So when we monitor, these are the things that we care about. So up until now, how did we do that? Well, until just a couple of years ago, our system looked a little bit like this. And arguably, it's still in the transition phase. The primary thing I want to talk about today is how we've moved from where we were just a few years ago to where we're going in the future with Elastic. So we were already using the beats agents, metric beat, heartbeat, file beat, and we were forwarding that data into Logstash, doing some processing on it there, and then shipping that data into Splunk. DOE is a very large Splunk organization. That was the tool that we were sort of beholden to use. And we did a lot of very interesting things with it. I like to think they're very interesting. I was also the reason a lot of them got built, so maybe I'm biased. We built a number of compliance dashboards in Splunk. I think these are very similar to the types of things that the CDM dashboards that CIS is building might entail. A lot of the same sorts of goals. One of the interesting things about the national labs is we're several layers down from DOE proper, which means that some solutions or capabilities don't necessarily make it all the way down to us, and sometimes we have to build our own solutions. There's also that whole programmatic role of, well, the program has to decide what actually is important or what logs are important to gather. There's not a very prescriptive list of these are the particular log files to gather. So we built some dashboards to track things like what operating system versions are our clusters at. We tend to upgrade these all in lockstep. Across a couple of months. We actually produce our own operating system, TOS, which is basically a fork of Red Hat. And we run our own compliance baselines based on whatever guidance is relevant, NIST 853, CIS benchmarks. We recently published a STIG for our HPC OS. That was a big win this last year. And we've been able to build out increasingly drilled down views of this, right? This I don't think is anything new to this crowd. We've continued to refine what actual information we're presenting. And what I'll say is that my team, the team that I lead, we are both the ones charged with standing up this infrastructure, maintaining this infrastructure, creating these dashboards, and actually the consumers of it. So when something's wrong, we have an impetus to actually try and fix it. And generally, we're looking for things to be in a pretty happy state, but we lose a lot of visibility. So this is where the story starts to change. We'd been in Splunk for a long time. We had a solution. It mostly worked. Some of the hardware was a little aging. Things were getting a little slower as we got increasing amounts of data into the system. And a couple of years ago, we had one of our engineers who was the new person tasked. Some changeover in staffing meant that she was now the one in charge of looking at our Logstash and file beats, metric beats infrastructure, and deciding how to evolve that forward. And we're staring at it. She had went off to do some other Elastic events, found that Elasticsearch and Kibana are there. Why are we not using a fully integrated platform? And this really honestly kicked off a bit of a bake-off. So we had the discussion internally. Could we update our Splunk infrastructure and just use beefier hardware, beefier nodes, more storage, more compute? Should we move to Elastic? Start asking around. We talked to some of the folks at Oak Ridge National Laboratory who informed some of this decision about their move from Splunk to Elastic and the performance gains that they'd gotten out of it. And after the course of a couple of months, we decided that, yes, in fact, we do want to give Elasticsearch and Kibana a chance and really dive into the Elastic ecosystem. So our experience is kind of unique, I think, in the room, but maybe I'm not correct, in that we're very much early in the process. We're just still inside of our first year with Elastic, and it has been a kind of an interesting road. And so I want to lay out what that first year has looked like. If you're someone who's been with Elastic a long time, maybe this does or doesn't resonate with you. If you're someone considering Elastic, this was our experience. Yours may be similar or different. So this decision to migrate to Elasticsearch and Kibana really led to one thing, which was we're going to change everything. So we looked at the entire infrastructure from the ground up, from the hardware we were running, to the dashboards we needed to use, to how are we actually reporting and alerting on this information. And the reality is that by the time we're done with our full migration, pretty much everything will have changed. And as we continue to dig into our data, this is just the fact of life, is that things change and we need to adapt with that. So after we made the decision to move to Elasticsearch and Kibana, kind of full Elastic stack, we spent a couple of months interacting with Elastic engineers and fleshing out an architecture. The timing actually worked out in a little bit of maybe a different ordering, in that we as an organization had already procured hardware to do a Splunk hardware refresh. And so we were able to just take that hardware and repurpose it for our Elastic stack and move forward with that. What that lost us, though, was the ability to actually buy hardware specifically for Elastic. So this ended up, of course, going through procurements, and of course the supply chain has been completely stable the last couple of years, and so that turned around very quickly, or not. We also went through, kind of a little bit of sitting back and watching and waiting for things like Elastic 8 to come out and get a little bit of feet under it, and keep an eye on that. And so by about April or May, as we started to get into our first license, we had our first version of our architecture. We were going to do a number of different Elasticsearch instances. We were going to arrange the Kibana instances on these nodes. We had these two different distinct underlying what we would call an HPC cluster that would consist of one Elasticsearch cluster, and we were going to put them in different buildings so we could have things like turn one entire building off and leave the other one on and still be able to collect data as needed. And what was interesting is we went through a period where we recycled and went through this architecture repeatedly. We spent quite a few months going back and forth, discussing the architecture, learning ourselves, right? The team that we had built up to take over Splunk, that became now building out Elastic, is not the people that originally built Splunk. It was not the people that had originally written the Beats deployments and the Logstash pipelines. Those people are not available to us right now. And so we were really learning as we go, trying to figure out the right way of doing it, and also trying to adapt, because we had this opportunity to redesign everything we wanted, to adapt to what was Elastic investing in the future. Is it really Beats that we should go with? Is it the new Elastic Agent that we should go with? If it's the Elastic Agent, do we do a tarball install? Do we do the RPM install? What are the benefits? Do we do containers or not? Do we do OpenShift deployments or not? And so for us, it ended up continually kind of churning through that discussion several times. And ultimately what we learned is that we had to unlearn everything that we'd done. So very early on in the calls with the team on my end and the team from Elastic, the mission that I put out was that we would be able to renegotiate everything. That nothing that we had created, even if it had taken 3 years, was sacred and had to be left in place. That we had the opportunity to rebuild whatever we needed to end up where we wanted to be. So we spent another couple of months, got through May and August, ended up with our second version of our architecture, and I think this is pretty much where we've stabilized now. There's been a few tweaks, sizing, and these sorts of things. And in particular, I want to shout out to Chris Pavona, who has helped us with discussing that architecture, came out for an on-site visit last week, and Kent Brake as well, who helped pretty significantly in that architecture development. So in the latter part of last year, we finally had gotten all our hardware on site. We had finally gotten all the storage we wanted installed. We got our operating systems deployed, and we had started to make our way into pre-production. Then the holidays happened. We had one of our team go out on maternity leave, and so things kind of have been a little topsy-turvy for the last few months. But we are at the point where we're starting in pre-production, deploy out our agents to our hosts, gather up data, gather up logs, and pull things in. And so as I mentioned, last week we had an onsite. We sat down, we built out a number of things. Our goal, ideally, is that by the end of this calendar year, we'll have completely deprecated our Splunk installation in favor of doing everything into Elastic. So actually, one of the things we're looking at is migrating data out of Splunk and into Elastic. That's going to be an interesting journey to figure out all the formats that are in the existing Splunk data, the throw everything in there and figure it out later approach to the actually having to think about it in advance. And that's kind of where we're at right now. So we're not a fully fleshed out solution. We don't actually know yet what the performance will look like. We know what the claims are. We know what we've seen so far. And frankly, we know that our previous solution couldn't keep up. Something had to change. And so this is kind of what our environment looks like now. So we have our HPC clusters, again, something like 200 of them scattered across different networks. They have some number of nodes. Those nodes typically aggregate log data to a centralized logging management node. That node is now running the Elastic agent, making use of whatever integrations we can. We are, for the moment at least, trying to push off using a Logstash and running the Elastic agents directly into Elasticsearch. Again, trying to follow that wave of where the trend's heading towards. We do know that there's some places where we probably will need Logstash, and some of the agents seem to basically act as a Logstash server in some cases, like for firewall data, pulling in data from firewalls, from those integrations. We're still building them out. We're working through all the different issues that I'm sure folks that have done these sorts of deployments and integrations can commiserate with me on. We're integrating with ServiceNow and finding that an integration doesn't work out of the box. We're having to work through some of the issues there. Working through tying this into our different applications and taking advantage of capabilities we didn't have before that we want to leverage in the future. One of the very exciting to a lot of our staff members that are, because we're the division that supports the users, we have a customer service group that gets a bunch of calls. We have a bunch of documentation spread across umpteen number of sources, Confluence, static websites, Jira, GitLab, the list goes, and multiple instances of some of those. We're looking at enterprise search as a way to search into all those data sets. Some of the permissioning isn't quite there yet, so these are some of the things that we're having to plan out when this will be available and how we'll make it available, how we'll actually structure this, and whether it'll just be a staff resource or whether we'll actually be able to provide this to our users is an interesting idea. It's an interesting new opportunity that we didn't have before. But this idea of having a centralized search across all our documentation pages, wherever they may be, is very enticing to us and has been something that's been discussed internally for a number of years now. So we have our agents sending to Elasticsearch, making our visualizations in Kibana. We're still in the process of building that all out. We have a number of legacy dashboards that we're moving over to Elastic, but we're also trying to not recreate a dashboard that we had made in the past if we don't need it anymore. Things like built-in integrations, or the available integrations and their built-in dashboards might solve a need for us that we previously had to write something that was our custom thing, but we might not need it that particular way. It might be met by another need as well. So where are we heading? Why is this relevant? Why is the timing of this so important? Well, for those of you that are maybe following the laboratory, maybe looked into it a little bit after you heard that Ignition announcement last month, we're heading towards El Capitan. So El Capitan, for those of you who haven't been to California, is that one on the left. Half Dome is kind of down the valley. You can't actually see it. So El Capitan is a procurement that we're doing. It's going to be sited at Lawrence Livermore. Typically, the largest supercomputers move around the DOE complex, so no site gets sort of sequential biggest supercomputer. So Oak Ridge was last, we're next, I believe Argonne is after us. The sites move around, partially to spread the load, partially just to give the engineering teams time to rebuild what has to be done. So we tore out Sequoia, which had a lifespan from about 2012 to 2020. over COVID, and are currently have our floor ripped open while we're piping in all the new water cooling lines we need for that. This system is expected to exceed 2 exaflops of compute capability across thousands of nodes. It's HPE contract AMD hardware. And if we go back to look at what our users see of our center, the performance capabilities available to our users, this is what it has looked like, and El Capitan becomes the star in the solar system of these things, kind of dwarfing all of the rest. So the amount of data that we've been collecting and the amount of data we're about to start collecting is at least 2 or 3x what we'd been doing, just with the entire rest of the center. And of course, because you can't just scale up in one direction, we're not just going to be collecting the same sorts of log and system level data that we were. We also want to start doing more low-level performance metric gathering, things like network timers, clock timers, low-level hardware metrics across the system to be able to do either debugging of issues, right? This is a new system being developed in cooperation with HPE. It's not just like they're delivering a system and walking away. It's a full integration process. So they'll be working with us, and we'll be working with them to discover where the issues are in this hardware. Right? This is effectively a custom hardware solution that's been built for us to meet this goal. And all of that data is now additional data that this particular logging infrastructure never had to take advantage of before, never had to ingest, never had to handle. And we were already starting to see, again, some of the performance impacts of the data we already had in our Splunk environment. So looking ahead, where are we going, right? I said we're coming up on about a year. We're still continuing forward with Elastic. We haven't seen anything that tells us that this is not the right path to go down. In fact, we've seen a lot of indicators to the opposite. We've seen a lot of indicators that tell us this is the way we want to go. Things like the Elastic Agent provide a really great integration framework. It's a little interesting how that will fit into our deployment process. The way we manage our HPCs tends to be kind of all the packages get deployed together and you get one diskless environment, and it tends to be stable for our users for some period of time. So things like continuous updates of agents is always a little tricky. How those things interact with file systems is a little bit of an interesting question. We've seen this with other like scanning tools. Anyone that's ever run the Nessus agent from Tenable on a system, one of the things it likes to do is actually walk entire file systems. Well, in our environment, the same file system is mounted across 10,000 nodes, and if 10,000 logging or agents try to walk that file system all at the same time, you end up with some pretty big performance impacts. In addition, you'll probably never actually walk the 100 petabytes of storage. So this is where we're going. We're moving nodes around in the cluster, right? Up until and through last week, we were still refining our architecture, still learning from what we've done, and trying to take advantage of whatever new features are developed. We're working closely with Elastic to actually feed back either suggestions or improvements or bug fixes. We're pretty sure we caught one last week with our fleet deployment that was kind of interesting. And as I said, the enterprise search has been one of the big, this could really be a big impact for us going forward, where we would be able to provide, ideally, for our users at a user permission protected level, the ability for end users to search across all the different places they might store their documentation. So this is where we're at now. This is where we're going forward. If you are using or thinking about using Elastic, right, this has been our experience. I'm pretty open about it. The nice thing about the way that our division works is we're pretty able to talk openly about the work we do in our part of the world. The application, the mission is maybe not so open in all degrees, but the actual underlying infrastructure is. It's a big collaboration, partnerships with many laboratories, many vendors. And so I would love to chat. So if you're someone from, particularly the US government, DOD, if you work on, some of the high side environments and you've, had run into some of the issues, have lessons learned, want to trade notes now or in the future, I'd love to connect. Thank you very much.